Greetings, welcome back to video lecture series on computer architecture. My name is Dr. Prashant Bachanna. So in this video lecture, I will be discussing about control memory, address sequencing, microprogram example and design of a control unit. So first we will discuss the control unit. So the control unit was historically defined as on distinct part in the year of 1946. So the reference model of with the reference model of Van Neumann architecture, there are basically two types of computer architecture: hardware and Von Neumann architecture. So the function of the control unit is to generate relevant timing and control signals to all the operations in the computer. So that is the purpose of control unit, that the control unit controls the complete operation of the computer, whether to start the operation or stop the operation. So the design of a control unit plays a very important role. So the control unit also controls the flow of data between the processor and the memory. So in the computer there will be a processor and the memory. So the flow of data between the processor, memory and the peripherals like I/O devices. So all these things will be taken care by the control unit. So control unit plays an important role for flow of data between the processor, memory and peripherals. So the example of the devices that require control unit CPU and for example are the graphics, that is the processing unit GPUs are the example for this. So these are, let us see some of the functions of control unit. The control unit directs the entire computer system to carry out the stored program instructions. So whatever the stored program instructions are there in the computer, so the control unit will give the directions or directs the computer system to carry out all those programmed instructions. That is, we will see like the control unit communicate with both the arithmetic logic unit and the main memory. So the first part the function is the control unit. The control unit will communicate through the ALU and the main memory. So the control unit communicates between the ALU, that is responsible for performing arithmetical and logical operations, ALU and the main memory, and the control unit instructs the arithmetic logic unit which logically or the arithmetical operations to be performed. So also the control unit is responsible for performing arithmetic and logical operations. So apart from this, the control unit coordinates the activities of the two units as well as all peripherals and auxiliary storage devices linked to the computer. So these are some of the functions of control unit. That is, the main function is to make a communication between the computer, all the components of the computer, that is ALU and the memory, and to perform all the operations like arithmetic and logical operations and the coordination between the peripherals. Then now there are two types of control unit. We'll see the types of control units. So the control units generate the control signals using the two organizations. So there are two types of control units. That is, the first one is the hardware control unit, and the second one is a micro program control unit. So these are the two types of control unit we can generate. So we'll see it one by one. So in the hardwired control unit is implemented through the use of the sequential logic. That is, basically there will be two types of circuits, that is combinational circuits and the sequential circuits. The sequential circuit will have the memory. So that is the reason. So the hardware control it uses a sequential logic units or the circuit like the gates, flip-flops, decoders are in the hardware, so that it will have some sort of the memory. So the hardware control units are generally faster than the microprogram. So as if you compare a hardware with the microprogrammed unit, so the hardware control are more faster as it is having the memory. So this architecture is preferred in the RISC architecture. That is the hardware control unit is used in the RISC architecture. So there are basically two types of architecture we have seen earlier: RISC and CISC. So RISC stands for Reduced Instruction Set Computing, and CISC stands for Complex Instruction Set Computing. So either our computer will have the RISC architecture or CISC architecture. So depends on the requirement. So we will be using the two types of the control unit. So the hardware control unit will be used in RISC computers. Then the hardware approach has become less popular as compared as was evolved at one time. So the control units of the CPU were ad hoc logic and they were difficult to the design. So the hardware control, since it consists of lot of hardwares like flip flops, decoders, and this thing, so it is not that famous. So we'll see the advantages of the hardware control unit. That is, it is fast because the signals are generally by the combinational circuits. Then the delay in the generation of the control signals depends on upon the number of the gates here what we are using. Then the performance of as compared to the microprogramming unit is high here. So these are some of the advantages. So when it comes to the disadvantages, the hardware control signal in the hardware architecture, hardware control unit, the control signals required by the CPU will be more complex. So the control signals will be more complex here. That is modifications. Then in control signal are very difficult. That means it requires rearranging of wires in the hardware circuit. So if you want to change any of the control signals, it is very difficult because since it is made up of the hardware components like flip flops and other things. So it is difficult to correct the mistakes in originating the design or adding the new features. So since the hardware control unit consists of the hardware, so it is very difficult to rearrange the design or rearrange the control signal since it is made up of some sort of hardware components like flip flops and all. So we'll see some of the architecture of the control unit. That is, it consists of two decoders here. It will like two decoders here. This 3:8 decoder and this is 4:16 decoder. So here is a sequence counter of 14-bit. So with this we are having an implementation INR, increment, clear, and the clock here. So here is our control unit gate. So which is made up of either the hardware or this one. So here we will be having some inputs here. So here the instruction consists of the two parts, that is opcode and the address. So it will be given to the decoder with the help of this. The control, all the address will be given. The decoder decodes it. So control signals will give the instructions to the ALU for performing all the operations. So this is the output of the control unit. So this is the architecture of the control unit, wherein it consists of the decoders and sequence counter. With the help of this, it will give the commands to the computer. That is, it controls the operation of it gives the commands to control the operations. So this is a timing diagram. So as it you can see the clock as on different time clock cycles, the control unit will give the different signals based on this, and this is a clear operation here. So what is the role of role and the functions of the control unit? So what is the basically roles of the control unit? That is fetching the instruction, decoding, and execute. So in a computer, the role of a control unit will be fetch. 3 steps will be there: fetch, decode, and execute. So fetching the instruction, that is it retrieves the instruction from the memory. Then decode the instruction, that is it interprets fetch instruction to understand the required action. That is in the decoding, in the sense what operation to be performed, whether the ALU has to perform any arithmetic operation or logical operation or any other kind of operation. So the decoding, in the sense it has to interpret what operation to be instructions to be executed. So then once it is decoded, the execution of the instruction is done. That is, it directs the data path and the control signals to perform the operation. So with the help of the data path, the data will be received, and with the help of the control signals, the operations will be performed. That is, also the function of the control unit is to control the data flow. So whatever the data flow is there, so it controls the data flow. That is, manage the transfer between the various components. Since there will be n number of components present, so it has to manage the data flow. That is the transfer of data between the various components. Then, as you have seen, like already, two types of control units are there. That is hardware control unit, that is use fixed logic circuits to control the signals. So it is very difficult to change the control signals. Whereas in the microprogram control unit, we will write the programs. That is, we use micro instructions stored in the control memory to produce the control signals. So compared to the hardware control unit, microprogram control units are more flexible. Complexity is less in microprogram control unit, and it is easily we can do the modification. So there are basically two types of control unit available. One is the hardware control unit, which is made up of the logic circuits, circuits, that is the components like flip-flops and other things. So it is very difficult to implement the hardware control units, and it is very difficult to modify the hardware also. So compared to this, the microprogram control units are very flexible, and here it is having less complexity, and the ease of modifications is very easy. That is, the modifications can be done very easily since we are writing the micro instructions. So that is the hardware control unit. So already we have seen the structure consists of the logic circuits. So the operation is control signals based on the instruction of the opcode. Advantage is it is a fast execution compared to the hardware one, microprogram one, but it is difficult to modify and update, as you have seen earlier. Whereas microprogram, the structure is it utilizes the sequence of micro instructions stored in the control memory. So in the microprogram control unit, so we will be writing the micro instructions which will be stored in the control memory. So here the operation will be, so each micro instructions, whatever the micro instructions we have written in the control memory, so each micro instruction will perform a specific set of operation, and it will have the specific control signal here. So compared to the hardwired one, it is having the advantage that it is easier to design, and we can modify also, since we are writing the micro instructions in the control memory. So we can easily change the program, that is instructions can be changed easily. Whereas in case of hardwired one, it was not possible because it is very difficult to change the hardware there. So the only disadvantage with this microprogram control unit is it's generally slower than the hardware control units, because here we have to depend on the instructions which are stored in the control memory. So now we'll see about the control memory. So we have been writing the code in the instructions in the control memory. So we'll see what exactly is the control memory. So the control memory is a memory which is used to store the micro instructions of the control unit. So whatever the control unit we are having, which is the heart of the computer, which basically controls the whole computer. So here the control memory is a memory which is used to store the micro instructions of the control unit. So this control memory is basically made for only storing the micro instructions of the control unit. So here the role of the microprogram control unit, that is, it stores the microprogram that controls the execution of the machine instructions. So again, like here, again in the types of the control memory, again we have ROM, that is the read-only memory, that is it's a permanent storage of micro instructions. That is in the RAM, random access memory, temporary and changeable storage. So all our operations will be performed with the help of the RAM. And then we have one more memory which is called as PAD, that is programmable logic array. So which is customizable with the logical circuit. So in the programmable logic arrays, we can change the logic, or the operations can be modified n number of times, and it can be programmed any number of times. So these are like in the control memory. So it is basically used for the control unit only. In this we have different types of memories. So already we know the very basic ROM, that is it's a non-volatile, used for fixed microprograms, whereas RAM is used for flexible and update of the microprograms. So PLA already you know is like flexible of RAM and the speed of the ROM. So the next topic of discussion is the address sequence. That is the process of determining the address of the next byte instruction to be executed. That is address sequencing. So as a computer receives n number of instructions, so we have to sequence those instructions. So that concept is called as address sequencing. So the importance is ensure a correct execution flow within the control unit. So here there are different types of methods of addressing, that is linear sequencing. So in the linear sequencing is very simple and straightforward progression. And in the second one, conditional branching, that is it alters the sequence based on the conditions here. Then mapping techniques, so we can sequence the address, that is the instructions to be one by one with the help of the lookup tables for complex sequencing. So there are three ways of address sequencing, that is linear sequencing, conditional branching and mapping techniques. So in the linear sequencing, basically what will happen is sequential execution of the microprograms will be executed. That is sequential in the sense the one by one the instructions will be executed. Whereas in case of conditional branch, so the microprogram counter is updated based on the specific condition. So here based on the specific branch, it will go to the particular branch, and based on the specific condition, the instructions will be executed. Whereas in case of linear one, the instructions will be executed one by one. And whereas in case of mapping techniques here, it uses the address mapping to jump to a specific microcontroller addresses. So if you want to execute a specific instruction, so with the help of this mapping techniques, we can use we can execute the instructions. That is now our next topic is microprogramming. So what is, we are telling that like we are using the program writing micro instructions. So a method of designing the control unit where micro instructions are used to implement machine level instructions. That is microprogramming is a programming wherein we will be writing the micro instructions for designing the control unit in the machine level of instructions. So basically we'll be writing the instructions here, that is micro instructions for designing the control unit. So what is the importance of this microprogramming? That is, it simplifies the design and modification of the control units here. That is, with the help of microprogramming, we can do all these things. So here some basic terms you have to remember. That is, micro instructions means low level instructions controlling the individual operations. Whereas a microprogram means sequence of micro instructions forming a complete operation. So with the help of in the microprogramming, basically we'll be writing the micro instructions for the design of the control unit. See here, micro instructions in the sense it define the control signals for one or more cycles. Since the control unit basically sends the control signals, so here the micro instructions, that is in the micro instructions are used to define the control signals for one or more clock cycles. Whereas in case of microprogramming, so it is a collection of micro instructions, you can say. So micro instruction is the one instruction and microprogram is the collection of instructions. And then we have the control word, that is a binary representation of the control signals. So we'll see an example of microprogramming example, that is we'll see in the fetch and execute and add instruction. So what are the steps involved here? So first fetch the instruction from the memory, then decode the instruction, then fetch operands, perform the addition, store result. So this is how the example of so for this the microprogramming instructions are written here. See, for fetch you will be writing the programs. We have to use these ones and we have to increment the program counter by 1. Then decoder means the decoder IARE is to identify which operation. Decoding in the sense the decoder will identify which operation to be performed. In this we are performing add operation. So it will identify that add operation. Then it will be first loaded into the register with the operands. Then it will be executed and the results will be stored in the destination register. So this is an example of microprogram example how a control unit executes an instruction. So when it comes for the design of a control unit, so we have to consider some of the parameters here. That is the instruction set architecture, which one we are using, then the desired performance, then hardware constraints we have to see. Then the steps involved in the control unit will be design of the control signals, then developing micro instructions plays a very important role, and implementing the control logic. So we have seen the hardware design process, that is defining the state program, implementing the combination logic circuits, and optimizing. So the example of hardware control will be simple ALU operations. So microprogrammed design process already we have seen. For machine instructions it is there. So here the instructions are stored in the control memory, implementing the micro instruction in the sequencing. So the example of this microprogram will be fetch, decode, and execute cycle. So factors affecting the performance of a control unit. So what are the factors which affects the control unit performance? So that is execution speed. Here the execution speed plays a very important role for the performance of the control unit. Then the instruction throughput, how many instructions are executed. Then the flexibility and the adaptability. So these are some of the factors which depends, which controls the control unit performance, which will identify the performance of the control unit. Then optimization techniques, how we can do? We can use pipeline of micro instructions. In the sense, once the one instruction is executed, the next instruction should be in the pipelining. So in the pipelining architecture, the instructions will be executed one by one. So when present instruction is being executed, the next instruction will be in the pipeline. So with that we can save the time as well. So we can improve the performance of the control unit. Then we can use the parallelism also, so that in the parallelism we can execute more than one instructions at the same time. Then we can use efficient address sequencing. That is the different. We can use the efficient address sequencing properly, so that the control unit execution speed will be more, instruction throughput will be high, and it will be flexible and adaptable. So impact of AI and ML, that is intelligent control unit adapt to the workloads, then prediction of execution of the optimization. Then emerging technologies on this one will be graphene and novel materials, so 3D integration and control logic. So these are some of the like the summary, that is importance and the role of control unit. Then types of control unit we have seen. Detailed lookup at the control memory, address sequencing, and microprogramming we have seen, and design consideration of examples of the control unit. So these are the topics that we have studied. So the importance of control unit in modern CPU is critical for efficient and effective CPU operations. That's all for the today's lecture. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.